Hi all, in this video we are going to learn about phasor diagrams and phasor algebra. This is our sixth video on the playlist of AC circuit analysis. The definition of the phasor is a complex number that represents the amplitude and phase of a sinusoid is called as phasor. So here from the definition, there are two important parameters we can have to represent by the complex number. So here those are the amplitude and phase. So for an example, I am considering for the example I am considering the equation Vt equal to 3 cos omega t plus 30. So here this 3 represent the amplitude. Here the 30 is an angle. So likewise, if we write this equation into complex form, we can write as V dash equal to, here the amplitude is 3, angle 30 degree. So this is the way we can write the same equation in the complex form. Likewise, for the phase corresponding by the RMS value, again we can write as V bar or V dash equal to 3 by root 2, angle 30. Because previously we have learned that for the RMS value, to find or to convert the RMS value, we have to divide it by root 2 of the maximum value. So the maximum value divided by root 2. That's why here the maximum value or the amplitude is 3. So we have to divide it by root 2. The angle is 30 degree. Rectangular form of a complex number z equal to real of z plus j into imaginary of z. So this is the format to represent the complex number into the rectangular format. So here the real number of z is, for an example, I am considering as x. Likewise, for the imaginary number of z, I am considering as y. So now again we can write the equation as z equal to, here for the rez, real number of z, that is x. So x then plus j into, now we can substitute for the imz. Im means imaginary number of the z. So that is we have to take as y. So this is the way we can convert the complex number into the rectangular format, z equal to x plus jy. Okay, now let's move for the polar and exponential form of a complex number. So the format is z equal to magnitude r into angle theta. So here the r is a magnitude value, here theta is a phase value. So now this is a polar form of a complex number. Now let's see the format of exponential form for the complex number. So again, for the exponential form for a complex number can be written as z equal to r into, r is a magnitude value, into exponential e to the power j theta. So as I said earlier, r is a magnitude value, theta is a phase value. Relationship with polar and rectangular format. When r and theta are given, we can find an x and y. Or when x and y are given, then we can find r and theta. For example, I am considering a complex number z equal to x plus jy. So this is our complex number. So now by using the rectangular coordinate system, I am going to plot a graph. So to plot a graph, we have to select x-axis and y-axis. So this is our y-axis. This is our x-axis. So the x-axis will be real number and y-axis will be imaginary number. So now we have to find out the coordinate. Here the x is a magnitude value. So from the x-axis we have to mark down the point x, and from the imaginary axis we have to mark the value y. So from the origin to the point, we can draw a vector. So from this rectangular coordinate system, this one r will be magnitude value. So this angle I am considering as theta. Now from our complex number, the value x and y are given. So now let's find the value for the r. R is a magnitude value. To find the r, we can use the equation r will be equal to square root of, here this one is a right angle triangle. So here the r will be x square plus y square. So now even we can find the tan theta. The tan theta will be y over x. So from this we can take out the theta. The theta will be tan inverse y over x. So now from this triangle we can find out cos theta also. So the cos theta will be x over r. So from this equation we can take out, or we can find the value for x. So the x will be r into cos theta. Likewise, we can find sin theta. The sin theta will be y over r. So from this equation we can find the y. The y will be r into sin theta. So this is the way we can find x and y. Now finally our complex number z will be equal to r into, within bracket, cos theta plus j into sin theta. The idea of a phasor representation is based on Euler's identity. So the Euler's identity will be e to the power j theta equal to cos theta plus j into sin theta. So now from this equation we can take real part and imaginary part. So the real part of e to the power j theta, instead of z, here we have to write e to the power j theta. That will be equal to cos theta. As I said earlier, here this one is the real part, this one is an imaginary part. So likewise, imaginary of e to the power j theta. That will be equal to sine theta. So let us assume our sinusoidal function Vt equal to Vm cos omega t plus theta. So now we can compare with our rectangular equations. That will be equal to Re, real of z, plus j into imaginary of z. So the Vt equal to Re real of, for the z we can write as Vm into, here we can compare, for the z here we can write as Vm into e to the power j. Here the angle is omega t plus theta. That's why. So again we can write as Re within bracket Vm into, here e to the power j omega t plus e to the power j theta. So we can write as e to the power j into omega t. Here addition is coming, that's why we have to multiply into e to the power j theta. I hope you will clear with this basic mathematics. So now here e to the power j omega t, we can subtract this one. So the remaining part Vm into e to the power j theta. So this is what we can write as complex of V bar equal to Vm into e to the power j theta. So V bar will be equal to Vm angle theta. This is an exponential form and also polar form. I have written the equation into two forms. Okay, now I am going to show you how to draw a faces on the complex plane. So my faces are V vector equal to Vm angle theta 1. My second phasor is I vector equal to Im angle minus theta 1. So these are my two faces. So now I'm going to draw the faces on my complex plane. So I have to draw x-axis and y-axis. So the x-axis represents, as I said earlier, real number, and my y-axis will represent imaginary numbers. So Re and Im. So now for the first step, let's draw this V vector equal to Vm angle theta 1. So this is the magnitude, this is the angle. So the magnitude we have to draw with the angle theta 1. So randomly I'm going to draw like this. So magnitude value of this phasor will be Vm, and the angle is theta 1. Theta 1 is a plus theta 1. That's why we have to choose anti-clockwise direction. So with respect to this x-axis, the angle will be theta 1. Likewise, let's draw the second phasor also. So here I vector equal to Im angle minus theta 2. So in the same manner, we can draw the magnitude of Im, the angle. The angle is something minus theta 2. Minus mean it should be drawn in the clockwise direction. So from here to here, the angle will be theta 2. So this is the way we can draw the faces on the complex plane. So the key point we have to note down is the phasor analysis is only applicable when the frequency is same. So when the frequency is same, then only we can go for the phasor analysis. Here for the v vector and I vector, the condition should be both of its frequency should be same. Otherwise, we cannot draw phasor on the complex plane. Finally, let's learn about how to draw a sinusoidal waveform for a particular angular frequency. So here, likewise, as shown in the animation, here this one is rotating into the anti-clockwise direction for the angular frequency of omega t. I am considering here the angular frequency is omega t. So for that omega t, it is creating a sinusoidal wave like this. Here it is creating a sinusoidal wave in between these two amplitudes. So likewise here also there are three different waveforms are drawn by three different amplitudes. So this is how we draw a sinusoidal waveform using a different angular frequency.